Okay, so today in Algebra 2, we're going to look at the second half of Section 2.4, complex numbers. We're going to pick up in the notes with multiplying complex numbers. Very important, you will never leave an I squared in your answer. You will always replace I squared with -1. So we're going to start out, find the product. So this says negative 2.5i times 8 minus 9i. We simply need to distribute the negative 2.5 with everything inside parentheses. So negative 2.5i times 8 gives us negative 20i. Negative 2.5i times negative 9i. So the negative 2.5 times the negative 9 gives us plus 22.5. And then I times I gives me I squared. My I squared always turns to -1. And then we want to remember that we always want to put it in the form a plus bi, so the real part is always going to come first. So 22.5 times -1 gives me a negative 22.5 minus 20i. So that would be our answer. The second one, we're going to do the same thing, distribute the 2/5 I. So 2/5 I times 10, that's going to simplify to 4i. 2/5 I times negative 5/2 I, the 2/5 and 5/2 cancel each other out, and I'm left with minus I squared. Again, the I squared becomes -1. I have a minus -1, which turns to +1. So I end up with 1 plus 4i. That's our answer. Now number 3, okay, we want to FOIL this. You know, the FOIL means first, outer, inner, last. So 3 times 3 gets me 9. 3 times 2i gives me plus 6i. Negative 2i times 3 gives me negative 6i. Negative 2i times 2i gives me minus 4i squared. Again, I squared becomes -1. So this turns to 9 plus 4. Okay. So 9 plus 4 gets me 13. My i's cancel each other out, so I'm just left with a whole number. If you notice there, the only difference between the two were the subtraction sign and the addition sign. So when that happens, that middle term that holds your i's is always going to cancel, and there's a shortcut that we can use. We simply square the first term, that 3, and then square the last term, and then subtract in between. So let's try that shortcut on number 4, because they're the same except for one's plus, one's minus. So I take my first term and I square it. So 1/2 squared gives me 1/4. Then I subtract the second term squared. So 2i, I have to square both of them. The 2 squared gives me 4. I squared is I squared. I replace I squared with -1. So now I have 1/4 plus 4. 1/4 plus 4 is 4 1/4. Or I could change that to a fraction, which is 17/4. Number 5. Notice I cannot use my shortcut method on number 5 because they are not opposites of one another. They have completely different numbers, so I need to go ahead and FOIL this again. So 6 times 2 gets me 12. 6 times -3i gets me -18i. 2i times 2 gets me plus 4i. 2i times -3i gets me minus 6i squared. My I squared becomes -1, so this is a -6 and negative plus 6. So 12 plus 6 gets me 18. Combine my i's, -18i plus 4i gives me minus 14i. I can leave it like that, or I can go ahead and factor out the GCF. So they both have a 2 in common, so I can pull a 2 out, and then I get 9 minus 7i. You need to recognize that those are both the exact same thing. All right, number 6, again, we're going to FOIL. 1 times 12 gets me 12. 1 times 4i gets me plus 4i. Negative I times 12, negative 12i. Negative I times 4i, negative 4i squared. Again, that I squared becomes -1. So this becomes positive 4. So 12 plus 4 gets me 16. When I combine my i's here, a positive 4i and a negative 12i gives me -8i. Again, I can do GCF. They both have an 8 in common, so 8 equals that 2 minus I. Again, I need to recognize that those are both the exact same thing. All right, the last page. We have what's called the complex conjugate, okay? A complex conjugate are complex numbers with equivalent real parts and opposite imaginary parts. The product is always a real number, so it's going to look like a plus bi times a minus bi. And again, we saw this on the previous page where we had the two that we were multiplying together. And I just told you that shortcut. So the shortcut says a squared minus bi quantity squared. From these first four, we're simply going to find the conjugate, identify the conjugate. 6 minus 17i, the real part stays the same, 6. I change the sign of the second part, so plus 17i would be the conjugate. 1 minus I, the conjugate 1 plus I. 81i, okay, I don't have a real part, so I don't need one. I change the imaginary part, I change the sign, so it's negative 81i. 2/3 plus 7/8 I becomes 2/3 minus 7/8 I for my conjugate. Last thing we want to talk about, simplifying quotients with complex numbers. It tells us, very important rule, you're not allowed to have an imaginary number in the denominator, just like you're not allowed to have a radical in the denominator. So remember in Algebra 1 geometry, we had radicals in the denominator. We called it rationalizing the denominator. We have to get rid of that radical. So again, you're not allowed to have a complex number in the radical, or sorry, in the denominator. You need to get rid of it. To get the imaginary number out of the denominator, you simply multiply both the numerator and the denominator by the complex conjugate. So number 1, 10 divided by 2 minus I. I have to get rid of that 2 minus I, so I multiply it by its conjugate, which is 2 plus I. So multiply top and bottom by 2 plus I. So on top, just distribute my 10. So 10 times 2 gets me 20. 10 times I plus 10I. All over. I'm going to use the shortcut for conjugates. So that says I take the first term, I square it. So 2 squared is 4. Always minus the second term squared, so I squared. Remember, I squared is always turned to negative 1. So on top, I have 20 plus 10i divided by, in the denominator, 4 plus 1 turns to 5. Now I need to simplify this. They all have a 5 in common. 20 divided by 5 is 4. 10 divided by 5, so plus 2i. Or I could pull that 2 out, make this 2 plus I. 2 plus I. Again, I need to recognize that those are the same thing. Okay. Number 2, 80 divided by 2 minus 6i. Its conjugate is 2 plus 6i. So I'm going to multiply top and bottom by 2 plus 6i. So on the top, again, I'm just going to distribute. 80 times 2 gets me 160. 80 times 6i gets me plus 480i. All over. My shortcut for conjugates, the first term squared, 2 squared is 4, always minus my second term squared. I have a 6 and an I square them both and get 36 I squared. Anytime I see an I squared, I replace it with negative 1. So on the top, I have 160 plus 480i. Over on the bottom, I end up with 4 plus 36, which is 40. Again, I want to simplify, okay? 40 goes into both of these on the top, so 160 divided by 40 gives me 4. 480i divided by 40 gives me plus 12i. Or I can pull a 4 out of this and get 1 plus 3i with the 4 on the S. Okay. All right, moving on to number 3. Negative 1 plus 2i, so I want to multiply top and bottom by negative 1 minus 2i. So on top, I'm going to have to FOIL, right? So 4 times negative 1 gets me negative 4. 4 times negative 2i minus 8i. Negative 3i times negative 1 gives me plus 3i. Negative 3i times negative 2i gives me plus 6i squared. All over. The first term squared, so 1 squared is 1, minus 2i squared, 4i squared. Why everything is moving on me today, guys, I'm sorry. So that's 1 minus 4i squared. Again, all of my I squareds I turn into negative 1s. So on top, I have negative 4 minus 6 gets me a negative 10. Negative 8i plus 3i minus 5i. Over on the bottom, I had 1 minus 4i squared. I changed the I squared to negative 1, so that turns to 1 plus 4, which is a 5. And again, I can simplify. Negative 10 divided by 5, negative 2. Negative 5i divided by 5, minus I. So there's our answer. All right, number 4, we're going to multiply everything by 6 plus 5i. On top again, I need to FOIL. 3 times 6, 18. 3 times 5i plus 15i. 2i times 6 gets me plus 12i. 2i times 5i gets me plus 10i squared. I know that I squared is going to turn to a negative 1. Everything over. First term squared, so 36 minus 25i squared. Again, the I squared turns to negative 1. So on top, I have an 18 and a negative 10. So 18 minus 10 gets me 8. 15i plus 12i gets me 27i. Over 36 plus 25 gets me 61. I see that I have an 8 plus 27i and a 61. They don't have anything in common that I can take out, but I need to recognize that this is the same thing. I can separate these fractions. This is the same thing as saying 8 over 61 plus 27 over 61. I need to recognize that those are the exact same thing. All right, number 5. 16 minus 5i divided by 2i. Notice in the denominator it's just a 2i. My conjugate is negative 2i. That's what I'm multiplying top and bottom by. So on top, 16 times negative 2i gets me negative 32i. Negative 5i times negative 2i gets me plus 10i squared. I know that I squared is going to become a negative 1. All over. Now I just multiply 2i times negative 2i gets me negative 4i squared. Again, the I squared I know turns to negative 1. Okay. On top, I have a negative 10. I need that to move to the front because I want the real number first. So I have negative 10 minus 32i. Over on the bottom, just 4. And take a 2 out of everything here. So then I get negative 5 minus 16i over 2. And again, I need to recognize negative 5 minus 16i over 2 is the same thing as saying negative 5 halves minus, okay, 16i over 2. 16 divided by 2 is just 8, so minus 8i. But those are the same thing. Okay? All right, one last one. 12 plus 7i times 2 minus 7i, or sorry, divided by, so I'm going to multiply everything by 2 plus 7i. So on top, 12 times 2 gets me 24. 12 times 7i gets me plus 84i. 7i times 2 plus 14i. 7i times 7i gets me plus 49i squared. I know my I squared is negative 1. All over my conjugate. So my shortcut, the first term squared, so 4 minus 49i squared. Again, my I squared becomes a negative 1. So on top, I end up with a 24 minus 49, which gives me a negative 25. 84i plus 14i leaves me with plus 98i. All over, 4 plus 49 leaves me with 53. Nothing in common that I can reduce, but I need to know that that's the same thing as saying negative 25 over 53 plus 98 over 53i. So that wraps up complex numbers.